Hello everybody, this is Leslie from purple.com, and this is another free bonus lecture for the Node.js masterclass. If you've been having trouble getting your API to work over HTTPS when you query it in Chrome or Postman, then this lecture is for you. In this lecture, I'm going to show you how to get that API working over HTTPS both in Chrome and in Postman. If you've been following along with section 3 of the course, you likely have already added a self-signed certificate like this one to your API so that it can run over HTTPS. But when you try to actually make a Postman request to it over HTTPS, or just visit the HTTPS URL in your browser, it probably didn't work. So this lecture has 4 parts. First, I'm going to replicate the error so we can all get on the same page about what the error is and what it looks like. Second, I'm going to explain why HTTPS is not working in your browser or Postman, and for that I'm going to need to explain what certificate authorities are and how they work on your machine and in your browser, and what a self-signed certificate is as it relates to certificate authorities. Part 3. For you users on macOS, I'm going to show you how to bypass these errors by adding your self-signed certificate to your trusted certificates in your operating system's keychain, and then rebooting Postman and Chrome so that it can work with your API without hitting these errors. Part 4, for all other users, everyone who is not on a Mac or is not using Chrome, I'll show you where to find step-by-step instructions for your particular operating system and browser so that you can bypass these errors. Part 1, let's replicate the error. Okay, for this I'm going to use the code straight from GitHub. I'll be using section 3, final. So this version of the code replicates close to where you probably are when you're first hitting this error. This is the API. I'll be starting it in staging mode, listening on port 3000 for HTTP and 3001 for HTTPS. I'm going to start it up with the node index.js command, and now it's running. Now I'll go over to Postman. You can see I can make an HTTP request, no problem. But when I add an S to make it HTTPS and change it to port 3001, I get no response. Similarly, I'm going to go over to Google Chrome and make a single request to localhost 3000. I get the response back, it works fine, but when I switch it to HTTPS 3001, I get hit with this "your connection is not private" error page. So that in a nutshell is the problem. This is likely very similar to what you're experiencing. An SSL error in Chrome and could not get a response in Postman. Everything being fine for HTTP, but everything breaking when you go over to HTTPS. So now let's go on to part 2 so we can understand what's going on here. Part 2, why isn't this working? The first thing to understand is that on a Mac at least, Postman and Chrome are very tightly coupled. Depending on how you downloaded Postman, it may or may not actually be a standalone app at all. It's likely just a Google Chrome app that is basically a browser extension built on top of Chrome. So all of its underlying networking and structure is actually inherited from Chrome itself. Even if you have a version of Postman that is not built on top of Chrome, it likely relies on the same certificate authentication mechanism that Chrome does, namely your macOS keychain. So in either case, when we fix this problem, we'll kill 2 birds with 1 stone. Fixing the problem in Chrome will automatically fix it in Postman. Okay, but what is the problem? Namely, if you followed along with the lectures, you generated the SSL certificate yourself. This is called a self-signed certificate. SSL certs have 2 components. There's the certificate itself and the authority, the certificate authority who generated it. And when a browser or a browser app like Postman attempts to read and validate the certificate, it looks at both of these things, not just the certificate, but the certificate authority behind it. If you're on macOS and you're using Chrome, the operating system itself actually has a list of all the certificate authorities that it knows and it trusts. And you can see that by opening up your keychain, like this, and clicking on System Roots. You'll see a list of certificates here. Many of these names are things you'll recognize. You'll see Thought, and Amazon, and Apple, and DigiCert, and Starfield Technologies, which is another name for GoDaddy, and here is Komodo. Now let's pick a website that runs over HTTPS so you can see how this keychain works in action. I'm going to pick the not so random website example of Node.js.org. When we visit the site, we see the URL is HTTPS. And the certificate is validated, and Chrome is telling us that it's valid by showing the word HTTPS in the URL and showing the unbroken lock next to it. Now, when I click this lock, I can get more information. If I click the lock and then click on certificate, I'll get more information about that cert. Here, we can see that the certificate itself, if we follow it up the chain, is actually issued by Komodo. That means that Komodo is the certificate authority for this cert. Now, if I go back to my keychain, if you remember, Komodo is one of the certificate authorities loaded onto my Mac. So when Chrome sees a certificate issued by Komodo, it trusts it automatically. Let's do another not so random example. Let's go to npm. Okay, I've gone to npmjs.com and I see it runs over HTTPS and it has a trusted certificate. I click the lock to get more information about it, click that certificate, and I see that it is actually issued by DigiCert. Again, when I go back to my keychain, you'll remember DigiCert is one of the trusted certificate authorities already on that list. But now let's go back to my localhost API and visit the URL. Now, when I visit localhost 3001, I can see that it still says HTTPS, but it's crossed out. And here, instead of a lock, it is just an alert. But when I click that, I can still click to get more information about the certificate. And it says this is a self-signed certificate. This certificate has not been verified by a third party. In other words, there is no valid certificate authority here that we know of. Nobody is vouching for this certificate, so we don't trust it. And this is why both Chrome and Postman are messing up. There's nothing wrong with your certificate per se, but they don't know who you are. You're not a certificate authority, so they have no reason to trust the certificate that you made on your laptop. Part 3. For macOS users, I'll show you how to bypass this problem. Back on this page where you're seeing an error, we can click the Get the Certificate, but now note that this image of the certificate is not just an image, it is actually the certificate itself. So I can click on it and drag it to my desktop. And now I have localhost.cer living there. Now when I go over to my keychain, I can drag localhost.cer into my keychain. macOS won't let you add things to system roots, but you can add it to your users' login certificates. So I'm going to click on it and drag it right here into the list of login certs. And now we can see localhost is added there. If I double click on it and click on trust, and then change when using the certificate from use system defaults to always trust, then I've just told my Mac to trust the certificate as you would any other certificate from a certificate authority. You may or may not at this point be prompted to enter the password for your user. After you close that window, if you see a blue plus sign next to your localhost certificate, then you're good, everything's fine. So go ahead and close your keychain, then close Postman and Chrome, and then reboot Chrome and Postman and retry your request. You can see I just retried it in Chrome. I'm at localhost 3001 and I'm finally getting the response. Nothing will change about the not secure message that is appearing next to the browser, but the request itself should work. Now, when you attempted to make the request in Chrome, you might have gotten through fine just like I did, or you may have hit another error about an invalid common name. If you see that error, click more details, then proceed anyway and bypass that error. That error basically means we don't recognize localhost as a valid domain name to serve HTTPS from. And by bypassing it, you're telling it, don't worry, everything's fine. Okay, now you should see some kind of response coming back from your API. Now I'm going to go over to Postman and repeat the request that gave me issues before, and you'll see I am getting a response back. Okay, part 4. This is for everyone who is not on a Mac or who is not using Chrome. If you want to get Postman to work, they have a great blog post on this subject which gives details for both Windows and Linux. So go to blog.getpostman.com. There you should see a search bar. Enter the query self-signed in the box. And this first result, the one published January 28, 2014, that's the one you want. The blog post titled Using Self-Signed SSL Certificates with Postman. Click on that and scroll down to the instructions for your operating system. You can skip by Mac OS X and go to either Windows, if that's what you're on, or Linux. Just follow those instructions and you should be good to go. So there you have it. I hope you enjoyed this bonus lecture, and I hope your API is running well on HTTPS now and you can query it in both your browser and in Postman. And if you're watching this but you haven't enrolled in the Node.js masterclass yet, please do. You can purchase it at purple.com. Thank you.